Section 6.1, the standard normal distribution. For these sessions, we do have two parts. First part, we will talk about the uniform distribution. Second one will be the normal distribution. Definition: a continuous random variable has a uniform distribution if its values are spread evenly over the range of possibility. The graph of uniform distribution results in a rectangular shape. So first, do you guys remember what is a uniform distribution? Uniform distributions talking about the frequency is about the same. Okay, and this is the perfect uniform distribution, and it will create a rectangular shape in here. The uniform distribution has two important properties. First one, the area under the graph of probability distribution is equal to 1. So make sure you guys remember that for the uniform distribution, the total area for this rectangle will be equal to 1. And there's a correspondence between area and probability or relative frequency. So some probabilities can be found by identifying the corresponding area in the graph. This is talking about area will be equal to probability. So if they are looking for the probability, means they're looking for the area. Okay, so you look at this uniform distribution. You could see the starting point here, the initial value is going to be A, and then the ending value is going to be equal to B here. And this is a rectangle. Total area under the curve is going to be equal to 1. So what is the height of this rectangle? Okay, we need to know how to figure out the height of the rectangle here. First, what is the area of the rectangle? Will be equal to the base times the height, right? Or the length times the width. So the base is talking about here times the height, which is going to be your h. And we already know area of this rectangle will be equal to 1. And then think about it. What is the base from here? What is the distance between here? That will be equal to b minus a. Okay, b minus a, talking about the length of the base here. And then we want to figure out what is my height of the rectangle, so I just put the h in here. Now we want to figure out what is the h, so we want to divide it by b minus a for both sides. Okay, this is an equation, so we want to figure out what is the h divided by b minus a for both sides here. And these two you could cancel out. So you could find the h that will be equal to 1 over b minus a. Okay, so it's going to be here. So every time when we're working on the uniform distribution, you need to figure out the initial value, the ending value, and also the height of the rectangle. And make sure you remember that the area under of this rectangle will be equal to 1. Chapter 5 consider only discrete probability distribution, but we now consider continuous probability distributions. The graph of continuous probability distribution is called a density curve. A density curve must satisfy the two requirements. Okay, remember chapter 5, we only consider the discrete random variable, and discrete means something by counting. For example, how many number of students do we have? So this is by counting. And for the continuous probability distribution, continuous, we could find it by measuring, like how tall I am, how heavy I am. And then we're gonna talk about the density curve. Density curve must satisfy the two requirements. First, total area under the curve must be equal to 1. The curve cannot fall below the x-axis. For the left-hand side here, this is the normal distribution, right? The bell shape. So this is one of the density curve. The area will be equal to 1 in here. okay, total area under the curve, under this normal distribution will be equal to 1. The curve cannot fall below the x-axis because we talk about area will be equal to probability. And probability is always between 0 and 1. So it's never negative, and that's why the curve cannot fall below the x-axis. And then on the right-hand side here, this is the uniform distribution. We have a starting point, ending point. We have the height of the rectangle, right? The base is 1, the height is 1. When you multiply it, so area is also equal to 1. And again, this curve cannot fall below the x-axis. And we call this is going to be the density curve. Okay, look at the first example. On average, 30 minutes TV shows have 22 minutes of actual program. Let's assume the probability distribution for number of minutes of actual program is uniformly distributed from a low of 18 minutes to a high of 26 minutes. I want you guys highlight the uniform distributed, okay? Uniform distributed. Uniform distribution, when you see that, you guys need to remember the graph is going to be look like a rectangular shape. First, graph the probability distribution. State the lowest value, highest value, and the height of the rectangle. Okay, the starting point here, this is uniformly distributed from a low of 18 minutes. So this is a starting value. To a high of 26 minutes, it's going to be here. And then now, figure out what is the height of the rectangle. Remember, we just proved it. This is going to be 1 over b minus a, okay? 1 over b minus a, which is going to be 1 over 18 here. Okay, this is the probability distribution with the lowest value, highest value, and the height of the rectangle. Okay, B, what is the probability the show will have greater than 25 minutes of programming? Okay, we will have the same picture here. And they want to find the probability, means they want to find the area. And the area will be greater than 25 minutes of programming. So 25 minutes is somewhere like here. And again, we want to find the probability, means we want to look for the area for this part here. Okay, looking for the area greater than 25. So the area of the rectangle will be the base times the height. Okay, the base is going to be 26 minus 25, which is going to be 1, okay, times the height of the rectangle times 1 over 8. So you're going to get 0.125. This is the probability that the show will have greater than 25 minutes of programming. Okay, C. What is probability the show will have between 21 and 25 minutes of programming? We will have the same picture. So think about it. How could you find the area in between 21 and 25? You should have the picture like this. And then we want to find the area in between. Okay, area in between here. So again, use the base times the height. The base was going to be 25 minus 21. The height is going to be 1 over 8. So you should get 0.5 here. So the probability will be 0.5 that the show will have between 21 and 25 minutes of programming. So this is the example for uniform distribution. One more time, every time when you guys see uniform distribution or uniformly distributed, think about this picture. You need to figure out what is the starting value, the ending value, and also the height of the rectangle. And one more thing, total area under the curve has to be equal to 1. Okay, so the total area under the density curve is equal to 1, and there is a corresponding between area and the probability. So area has to be equal to probability. Every time when they want to find probability means they are looking for the area. The standard normal distribution. For these sessions, we're going to learn the standard normal distribution. Standard normal distribution means the normal distribution, the bell shape, with the population mean equal to 0, and the standard deviation is going to be equal to 1. And also, the total area under each density curve is going to be equal to 1. Again, the total area under this curve is going to be equal to 1. And for the session 6.2, we're going to talk about the non-standard normal distribution. Non-standard means population mean cannot be equal to 0 or n. Population standard deviation cannot be equal to 1. Okay, since the mean is equal to 0, it's going to be in the middle. And the mean plus 1 standard deviation, that will be equal to 1. It matches with the z-score also. For this part, for the normal distribution, we still want to find the probability. And again, if we want to find the probability, means we want to look for the area. For the uniform distribution, since that's a rectangle, so we could use the area of the rectangle formula, just finding the base times the height. But since this is the normal distribution, this is the bell shape. We do have the formula to find out the area, but the formula is a little bit complicated. So we do have two ways to work on this kind of the question. First one, using your calculator. Okay, and this is what we're going to cover. Use the calculator to find the area. Or you could find the area using the z-score table, the table A2. For this class, if you already know how to find the area using the table A2, go ahead. Okay, if not, you could just use your calculator. Okay, using the TI-83 plus or TI-84 plus calculator. First part, if they given the z-score, find the area to the left or to the right, you'll be follow like this instruction. Okay, use your calculator. First, go to the second, and then you're gonna see the vase here. Okay, vase is gonna be next to the clear. Second, vase. You're gonna choose the normal CDF. The normal here means the normal distribution. CDF, this is talking about cumulative area, starting from the left to the right. You could see we want to use the normal CDF, lower value, comma, upper value, and then enter. Okay, for example, I want to find the area from the left. Okay, I want to find the area from here. So I'll be using the normal CDF. First, I need to plug in the lower value. Lower value is talking about the value from here, the smallest value. And recall this is going to be 1e99, negative 1e99. And this is means negative 1 times 10 to the power of 99. So this is a really, really small number. And we're starting from this point, that will be my lower value. Upper value, we're going to stop at here. Okay, which is going to be equal to 0. Okay, one more time. Normal CDF, the lower value will be negative 1e99 to the 0. So if you use your calculator, you're gonna see this is gonna be 0.5. Let me show it to you guys. I'm gonna choose number 2. Okay, negative 1e. E will be using the blue color here. Don't use the sign here. Use the comma one. So second, comma. And then 99. Okay, one more time. Use the comma one. So second comma, which is going to be the 99. And then upper value, we want to cumulative the area starting from this point until the 0. Okay, this is the standard normal distribution. Mean is always equal to 0. standard deviation is always equal to 1. And then place. Okay, lower value, upper value, mean, standard deviation. Enter. So you're gonna see this is gonna be 0.5 here, and which is gonna be make sense because the total area under this curve is gonna be 1. If we cut it half, the area on the left hand side should be 0.5. Area of the right hand side is also equal to 0.5. Okay, one more example. So let's say now I want to find the area to the right, okay, area to the right. So I will using the normal CDF again. This time the lower value becomes 0, okay, 0 to the biggest numbers in here, and we call 1e99. And again, 1e99 means 1 times 10 to the power of 99. This is really big number. So we want to find the cumulative area starting from 0 to 1e99. Okay, now use the calculator again. Second, bars, choose number 2, normal CDF. Lower value, we're starting from 0. Enter. Upper value will be a big number, 1 second, comma, 99. You have a 0 and 1. Okay, paste. And then enter. So again, you will be really close to 0.5 in here. Okay. Okay, guys, look at your calculator. If you're using the TI-84 Plus, do me a favor. You could see the mole in here. Okay, mole is going to be next to the second. And then go down. You're going to see the Z visor. Okay, Z visor here. Turn it off. Okay, make sure you turn it off and then enter. Okay, one more time. Go to the mole. Go to the stat visor. Turn it off. Okay, make sure you turn it off. Now you're gonna click on second mole. You're gonna be quick. When I do it one more time, I'm gonna go to the second bars, normal CDF. I could just put it in here. So I could put 0, 1 second, comma, which is gonna be your E99, close it, enter. You're gonna get the same answer. Just change it because some of your calculator, it doesn't look like the screen like this. Okay, so make sure you set it up, go to the mode, choose the stat visual here, turn it off. Okay, and then second mode to quit. Okay, let's try another example. Okay, using calculator to find the area to the left. So C-score, they given the C-score and you want to find the area. So normal distribution 1.26. So look at it, positive. 1.26 is somewhere like here. And then we want to find the area to the left. So we're looking for the area from the left. Again, that will be normal CDF. Right? The normal CDF starting from the lower value, negative 1e99 until 1.26. Okay, make sure put it in order from the left to the right. Okay, don't switch these two, guys. One more time from the left, this is the lower value, to the right. So that's going to be 1.26. You want to find the cumulative area starting from this point until 1.26, means like here. Okay, use the calculator. You will get this number. So the area to the left is going to be 0.8962. Okay, number 2, use a calculator to find the area to the right. So this time I want to find the area to the right when the z-score is negative 0.58. So negative 0.58 somewhere like here. And then we want to find the area to the right. So this is what we're looking for. So think about it. What is the lower value and what is the upper value? Okay, lower value starting at negative 0.58. Upper value, again, that with the big number, 1E99. Okay, use the calculator to see what you guys get. You're gonna get 0.7190. Okay, this is the area to the right. Okay, think about it, how to do the number 3. Try to sketch the picture and figure out what is the lower value and what is the upper value. Okay, find the area in between 0.42 to negative 1.45. Okay, so this is going to be the area in between. So when you have this, when you guys see the pictures, you're going to see the lower value will be this point, which is going to be negative 1.45. Upper value will be 0.42. Use the calculator. You should get this number. Okay, so this is the first part of the normal distribution. If they given the z-score, you know how to find the area, right? We will be using normal CDF, the lower value and the upper value. Okay, now I want to do it another way around. I'm gonna given the area and I want you guys to find out the z-score. And this time we will be using inverse norm. Okay, inverse norm. So similar procedure, you're gonna go to the second vase, go to number 3, inverse norm. And then you're gonna plug in the area to the left and then enter. Okay, TI-83 plus and some of the TI-84 plus will only ask you guys find out the area to the left. But that's a sum calculator. You do have a choice to choose the area to the left, in the middle, or the area to the right. Some calculators, just like my calculator, I only can put in like area to the left. So read the question carefully and make sure you know how to use your own calculator. If your calculator have the choice to put in to the left, in the middle, or area to the right, please write it down when you guys working on the homework and the midterm. Okay, you could put like the numbers here and tell me this is the area to the right or in the middle or to the left in here. Okay, example, use a calculator to find the z-score that has an area of 0.2643 to its left. So this time they given the area and then we want to find the z-scores. So first, you need to know how to sketch the picture with this information. Okay, I give you guys 2 choices in here. Think about it. Which one should be the right picture with this information? They should have the area 0.2643 to its left, okay, on the left hand side. So you will see both of them is talking about the area to the left. But which one is going to be the correct one? Give you guys the hints. What is the total area under the curve? Total area under the curve is going to be equal to 1, right? So if I cut it half, what is the area to the left? That will be 0.5 and 0.5, right? Right now you have a 0.26, okay? 0.26, which is going to be less than 0.5. So this one is 1. This one should be the correct picture. Okay, one more time. Total area is 1. When you cut it half, should be 0.5 and 0.5. 0.2643, which is less than 0.5. So this line should be closer, less than half and in here. So now you have the picture here. You know the area from the left is going to be 0.2643. So use your calculator. You're going to do inverse norm. Okay, in C squared equal to inverse norm, area from the left. You should get negative 0.63. Okay, negative 0.63. Double check your work, think about it. This is a normal distribution. When you cut it half, on the left hand side, that'll be the negative C squared. On the right hand side here, it should be positive C squared. Since your area here is less than half, so your C squared should be negative. Use a calculator to find the C squared that has an area of 0.68 to its right. Okay, again, I do have a 0.68 to its right. Okay, area to the right is going to be 0.68. So you have two pictures in here. Think about it. Which one should be the correct one? One more time, cut it half, it's going to be 0.5, right? 0.5 is going to be less than 0.68. Okay, so 0.68 should be greater than 0.5. So again, this one is 1. This is going to be the correct one. Okay, so you have this picture here. Now, we want to find the area from the left first. Okay, how can I figure out what is the area from the left? You could do 1 minus, right? So I'm gonna do inverse norm. Area from the left is gonna be 1 to total area. Take out the 0.68. Use the calculator. You're gonna get negative 0.47. Okay. You could use the calculator like this. Second, bars. Go to number 3, inverse norm. 1 minus 0.68, close, enter. You're gonna get negative 0.47. Okay, negative 0.47. Okay, find the C-score corresponding to P85, 85 percentile. Remember we talked about percentile on the chapter 3, right? We say we have the normal distribution, we try to cut it into 100 parts. Each part is about 1%. Okay, when we have a 1%, this is going to be your P1. If this is a P40, means this is a 40% area from your left. So right now we have a P85. So that's talking about you have a 0.85 to the left. So 0.85, which is going to be greater than 0.5. So I guess somewhere like here. And this is going to be the P85. So they given the area, they want you to find out the C-score. So again, you have the area from the left. So again, use the inverse norm, 0.85. Use the calculator. You're gonna get 1.04. Okay, number 7. Use the calculator to find the C-score that bound the middle 95% of the area under the standard normal curve. Okay, I want to find the z-scores, so I have a 2 z-score in here. That bound the middle 95% of the area. This is the in the middle 95% area, talking about the picture is going to be look like this. Okay, 95% means it's going to be 0.95. So area in the middle. So you need to figure out the z-score with this point and here. And first, I want you guys to figure out what is the area on the left tail and the right tail. Think about it. How can you find the area of the left tail and also the right tail? The total area under the curve is going to be 1, right? I could do 1 minus 0.95 and then divided by 2 because I do have a 2 tails. Okay, total area minus the area in the middle and then divided by 2 because I have a 2 tails. So you're gonna know each tail of the area will be equal to 0.025. Double check, add it all up, you should be equal to 1. Okay, first, we're gonna find out the z-score on the left-hand side here. So you already know the area from the left, so that will be inverse norm 0.025. Use the calculator. You're gonna get negative 1.96. Okay, so we want to figure out what's the z-score on the right-hand side here. So either you could do inverse norm, 1 the total area minus the area of the right tail. Okay, 1 minus the area of the right tail will be equal to the area on the left tail. Or you could do inverse norm, just add up these two areas. Okay, add up these two, that will be a total area from the left. You're gonna get the same thing, you're gonna see inverse norm 0.975. Use the calculator, you could get 1.96. And actually, if you know the area, this is in the middle, once you find the z-score on the left-hand side, you don't have to do it one more time. You could just write it down, make it like positive. Because the normal distribution, this is going to be symmetric, right? This is a symmetric. When they have the same area on the two tails, they should have the same z-score. It's just one positive and one negative. Okay, definition, net alpha being any number between 0 and 1. The notation Z alpha refers to the z-score with an area of alpha to its right. So for the alpha here is always between 0 and 1. When you guys see the z-score with a small number here, this is talking about the z-score with the area of alpha to its right. So for example, I want to find these numbers. This is going to be the alpha. My alpha between 0 and 1, this is good. And then this is talking about you will have the area 0.20 to its right. Okay, 0.20 to its right. Okay, one more time. You want to find the z-score with the area of 0.2 to its right. So I give you guys two pictures here and tell me which one is going to be the correct one. It should be the left hand side here, right? Again, cut it half is going to be 0.5. 0.5 is greater than 0.2. So this is going to be the correct pictures. So we need to figure out what is the area from the left, right? You'll be using the inverse norm, 1 minus 0.2. You could get 0.84. So the z-score in here, that will be 0.84. That's it.